This is Justin. I'm going to teach you today how to do backtracing, solving specifically the n-queen problem with Go language. Checking out this this graphic right here, n-queen is basically solving for a board of n by n, in this case 8 by 8, placing 8 queens in a way in which the queens are not attacking one another. So to simplify matters, we're going to place 1 queen per row, so we don't have to track the rows. We will have to track columns, and we'll have to track 2 diagonal directions. So you could see for this particular queen placement, there's 1 queen in a row. It's not attacking any queens in row 6. There's no other queens placed in column C, and then in the diagonal directions, you can see that there's no queens placed. So this particular queen is attacking no other queens, and likewise for all the others. This is a hard problem. We're going to use a concept known as backtracking, and we're going to use recursion to solve this problem. So to simplify matters a little bit, there is an equation for keeping track of the attacked diagonal directions. So for the top left to the bottom right, you can see the equation is it's row minus column. So like looking at that particular example, we placed queen at 1 1. You can see, for example, 0 0. So row minus column for 0 0. 0 minus 0 is 0. So we collect a list of, we process like all of the possible rows and columns, each place in this 2 by 2 matrix, and then anything that equals row minus column 0, you can consider it under attack. So in the case for 2 2, 2 minus 2 is 0. It's under attack in this top left to bottom right direction. Now the other simple equation to know for this, to simplify matters, is this the other direction. So we've got bottom left to top right. So in this case, I placed queen at 2 0. So the equation here is row plus column. So anything where the row plus column is equal to 2, you can see that you can consider this under attack. So you can see column row column 1 1, 1 plus 1 is 2. That's under attack, and then 0 2, 0 plus 2. That's in fact under attack. There's a train going by, sorry about that, but hopefully I can keep going without it interrupting too much. So to take you through the solution, again, backtracing, we're going to start this calling this function at row 0. Remember, we're going to use a concept known as recursion. So we're going to start at row 0, and then we're going to process each of the rows. I might have to pause for a second. Oh gosh, okay. This is so annoying. I hate this train. It's gonna sit here. Wow, that's loud. Doesn't bother the dog though. Dog is in the background sleeping. This is Amira. She is my she's my code reviewer. She reviews my code and watches TV. Okay, I think the train's gone by. So again, we're gonna go process each row at a time. We're going to first of all place the queen if we can. So if it's not under attack, we'll place the queen, and then we will calculate all of the diagonal directions that are under attack in those lists that we're going to create, and then we'll look at all of the columns that are under attack. We'll save that. So then in future placement of queens, we'll see if the space is available, And then, like if we cannot place the queen, so we will, or no, I guess in any case we'll backtrack to delete the saved information. So for example, suppose we place a queen and then we find out in the next row that it's not placeable, so we'll go backwards, but in order to go backwards in this recursion, we will have to delete the saved attack of that previously placed queen. So for example, suppose we have a diagonal attack and a column attack, and the queen didn't work out. So in the backtracing, we'll delete that information from the saved lists. So let's build this up, and I'll show you what I mean by saved lists and delete and backtracing and so on and so forth. So this requires an answer. The answer is a list of list string. Okay, of course we're going to return the answer. So we're going to save the columns and diagonal directions under attack. So these are lists to do that. So we've got a list of columns. We'll initialize a variable. It's going to be a list, a bool of size n. So for example, if this is a 4x4, we only have to have four places in this particular Boolean list of columns under attack. Diagonal 1. So what is diagonal 1 first of all? Diagonal 1 is it's the bottom left to the top right. And the equation again, just to refresh, is row plus column. So this is a list of all of those. So one quick thing to mention, so when we're making this list of Booleans that are under attack, it can't just be n, because look at this, it's row plus column, so it won't be large enough. So it should at least be 2n, so it's double the size. So we have twice as much size for this bottom left to top right diagonal list. So second diagonal list, this is going to be the top left to the bottom, what is that, bottom right. And this is, again, to refresh, it's row minus column. All right, so again, when we make this list, row minus column, we're going to make a list of bools that is 2n of size 2n. Cool. And then of course we've got to make the board. The board is going to be a list of string of size n. So this is a string representation of the board. Looking at the description, you can see that the type of answer that the output, when judging this, whether or not it's right or wrong, expects. This is the solution 1. So you can see it's a list of strings. In this case, 4, and then there's 2 solutions. It doesn't look like I can scroll down over my face, but just trust me, there's 2. So we've got the board. Now we're going to build it up. So we'll initialize it. So for I is equal to 0, while I is less than n, I will do I plus plus. So board of row, this is the row I, and then we're just going to fill it up with this string, this repeated string. And this is the first time we're doing this, so it's just going to be blank. Blank is represented by the period, so there's no queen in the initialized board. Looping through, it'll just do this for as many rows as there is in this particular problem. So then we've got n queen, and this is the recursive function that I'll write. And I'm going to do myself a favor, do you a favor as well. I'm going to copy the signature of this function up here, and I'll explain what I'm doing. So this is the signature of the function. The function is basically going to take n, which is the size of the board, or the number of queens. It's going to take the row that we're operating on. So we got to keep track of state when we are doing this, each of the recursions. So it will iterate going from 1 to 2 to 3 to 4, so on and so forth, when calling this function. And then, of course, we're passing our lists of places in which the row is under the column or the diagonal directions are under attack. So we've got our column list, we've got our diagonal list for bottom left to top right, and our top left to bottom right list, which is dig2. These are lists of bools, keep in mind, and this is just a list of when these are initialized initially. This would be initialized to something like false, false, false for where n is 3. So it would look like something like that. And then this is the column one. Of course, this would be there'd be for n of 3. There would be 6 for dig 1 and dig 2. And then we're passing the board, and of course a pointer to the answer. And this thing eventually will return the answer, and then LeetCode will judge our solution. So let's see. So first of all, what we're going to do is we're going to set up. We're going to remember this is processing one row at a time. So you can see the row, you can see which row number, and we're going to start out by passing, of course, n. We're going to start out by passing 0. We're going to start at the 0th row, the first row. We're going to pass the columns, diagonal 1, diagonal 2, the board, and the answer, a pointer to the answer, the address of the answer. All right. So first things first, what's the return situation? So if the row is equal to n, so if we're operating at the end of our, in this case, it's going to be 0, n will be 4. This will not be true the first time around. But the last time we call this function will be 4. So when n is 4, the row is 4, we want to return the answer. So we've got, we'll return here. And then, of course, the answer, I'll show you how that's done in a second. So we're going to build a for loop. We're going to imagine this now. So we're operating on the 0th row, and we're going to operate at one column at a time. So column will be 0, starting at the 0th column, while column is less than n, because remember this is n by n matrix. We will iterate over the column. So we'll start with 0, 1, 2, and 3. So here, this will be our return guard. So this is our guard for non-placeable queens. So if at the columns, this is the column we're operating on in this loop. So let's suppose this is 0. We've got this list of columns. If at the 0th place it's true, or the diagonal 1, which is our, again, diagonal 1 is bottom left to top right. If that's true, and remember, this is row plus column. That's our. This is going back to row plus column is diagonal 1. Making sure I'm showing you the right one. So we're looking into this list of places in which the the diagonal is false. So this is just simply a list of a list of where it's true. So if it matches this row plus column thing, so for example, in this example, if suppose we're trying to place a queen at 1, 1, so 1 plus 1 is 2. So if row plus column is 2, we have a true there, it's not placeable. So this would return in this case, and this condition would be true in this case. Or the third case, we've got diagonal 2. This is the row minus column. Because row minus column, if you imagine, will often get negative values. A hack here to add these in the reverse order would be this plus n minus 1. So this is just an interesting hack that I learned where we are adding in reverse order to this list instead of considering negative values. In the case that, and again, going back over this example, this is a different one. This is the top left to bottom right example. This is top left to bottom right is row minus column. So suppose we're trying to place it 0, 0. This is simply a list of these operations. So in this case, 0 minus 0, if we're trying to place in that place, it's 0. We would match on that 0, and you can see that would be true. And in that case, if it's true, it's not a placeable place where we could place a queen. So I know that's long-winded, but that is how we're keeping track of these non-placeable areas with these 3 lists. It's as simple as it gets. So we'll just continue. So again, just to reiterate, this continue means that if it's not placeable, we will simply try another column. So this is what that continue does. So we'll go to the next column. So suppose it is placeable. So what do we do here? So in the placeable situation, we're able to add our queen, and then we've got to amend. We have to update the variables, the column. So anything in this example G, we'd have to set as true, and then we'd have to do our top left to bottom right and bottom left to top right columns. So I'll do that right now. So we'll set trues here. So we'll look. We've got the list of columns. We're operating on one column here. Now this is true. So that means the next iteration, it's not going to be a placeable position for the next queen. So the next time we hit this queen function. So, and I'll show you how you do that in a second. So diagonal 1, this is row plus column. So this is the list of row plus column. This is true. And diagonal 2, that's row minus column. And then we have the hack, so we add it in opposite order, n minus 1. And that is equal to true. And then we're going to fix our board string. So we've got the row, and this is just a quick string operation we're going to do. So we've got the board at row, and then this is our string here, adding the queen, and then we've got the board, the rest of the string. Cool. Whoops. There we go. So this basically just replaces a period with a q. And then what we'll do here is we're going to call n queen again. So we're going to call n queen with everything except, everything will be the same except for the row. So we'll go to the next row, row plus 1, passing columns with the newly added, we've got the newly added true in that column position, newly added true in the diagonal 1 position, newly added true in the diagonal 2 position, passing the altered board with this new queen, and then we're going to pass this pointer to an answer. Cool. So you can imagine in a good situation what it's going to do is it will simply So basically, in a good recursion, it's going to it'll just basically place, and then place. This is for where n is 4, and then it will return. So it'll place, return, and it returns here. In this case, we're returning nothing. So let's return our answer real quick. So we've got a pointer to our answer. We're going to append to the pointer to answer a list of strings and our board, and we're going to return the answer. It's being returned. It knows it's returning because of the function signature. Okay. Let's see. So next, this is the interesting part. This is where we're going to do our backtracing, or backtracking. So we've got our backtracking here. So you can imagine that one of these. So you can imagine one of the levels of recursion wasn't able to place. So we have to handle that situation. So remember, we've added a true to all of these positions, but for one of the levels of recursion, it's no longer true. So to correct this, we'll just remove what we just added. So to quickly, we're just going to copy all this code and replace what we just added with true, false, and we'll remove the queen. So this cleans up. This backtracking will clean up our recursion. So this is you could think of this as the cleanup, and with this level of recursion, or the last time that the functions are called. So I think this should just work now. I think this is it. So like, this is very advanced. We have recursion, we have backtracking, and then we're handling simply a few lists, 3 lists to handle diagonal direction, diagonal 2 direction, and then of course the altered string. So let's see if this works. I might have to move this a little bit, and then I'll run the code. And I think it should just work. And we have a compiler. What is this complaining about? This is strings repeat, and then columns not defined, line 60. Oh, there we go. Oh, and it works. That's it. So this is n queen, and we solved it in just a few minutes. Thank you very much, guys. Goodbye.